Hi, my name is Lee Hansen. I'm with Xilinx Marketing, and I'd like to talk to you today about embedded processor co-debug. If you're an embedded system designer, you're very familiar with this issue. Your application guys have developed their C and C++ application code, they've run it against the IDE, and they found all the problems. It's running great. In parallel, your hardware guys have developed their HDL for dedicated logic, and they've simulated it on the design tools. And again, they've got all the bugs out, it's running great. But the minute you put the entire system together, hardware and software interacting with the processor, you start seeing bugs and problems and failures that you'd never seen before. And the problem is, they're not just straight software or straight hardware problems, they're system level problems. They're extremely hard to capture because they require the system tools to interact with each other. Well, Xilinx supports a feature called hardware-software cross-trigger with our complete embedded design suite. The Xilinx SDK software design tools can link with the Xilinx Vivado hardware design tools to help you debug and capture these types of issues. So now, software breakpoints can trigger a hardware data capture or vice versa. You can set hardware breakpoints to go debug and halt your application code, even do things like execute instruction trace. The benefits are your hardware guys and your software guys can drive and debug the tools from the environment they're comfortable with and capture all the data they need. So software guys can capture both software and hardware data. Hardware guys can capture both hardware and software data without having to learn the other tool. It saves you time. It saves you money. It saves them having to learn another tool set. Let's look at a quick demo. A quick preface before we dive in. The circuit I'll be demonstrating with today is part of a larger embedded design tutorial that you can download from Xilinx.com. I'll be moving rather quickly through this demonstration just to make sure the video stays short, but you can download this design file and I'll provide you the link after at the end of this video. Download the design files, download the instructions, our tools, and walk through this step by step. Create the hardware portion, the software portion, link those together and debug and run cross-trigger yourself. The heart of our system is going to be a Zynq processor. This is the Zynq 7000 SoC all programmable device, dual ARM A9 cores, literally the most advanced ARM A9 systems out there for programmable logic. When I started this design, I told Vivado that eventually I would target a 702 board, a Zynq evaluation board, and it knew what peripherals were turned on that board, so it set those peripherals for me accordingly. I can configure interface, peripherals, like I said, clocks, literally anything here, and Vivado will write all that hardware information out at the end for me. There are also a few peripherals that I've added to this design that will be placed in programmable logic. All of these came from the IP catalog that is delivered with Vivado, and you can add your own IP peripheral catalogs as well. I've already connected these up. There's literally a number of different options available in Vivado with IP Integrator that help you connect your system and validate your system. We just don't have time to go through them in this one demo. I encourage you, though, to go look at the other quick videos for both Zynq and Vivado to learn more about what your options are for design. So before I move on to synthesis and implementation, let me right-click one of these nets and notice this command option I've got called Mark Debug with the little green bug icon. In the design hierarchy, you'll see I've already marked 2 of these nets for debug. You can see it with a little icon. What that does for me is after synthesis, I can go into the tool and insert what's called an ILA core, or an integrated logic analyzer, that will let me set up the hardware portion of the cross-trigger debug. I've skipped forward to the output of synthesis, and I want to show you a couple of things here. The first is everything in the blue block is what we generated with Vivado earlier, the hardware portion of our design. But this yellow block is what's of interest to me right now. When I first came into synthesis output, I did setup debug. And what that did was let me read those signals that I had marked for debug earlier. And I can go now configure them the way I want to. For example, I can select a clock domain. In this case, I just selected the output of the Xilinx processing block, the main clock in the system. I did that for all the nets. That inserted for me the ILA core, and what I did was add both a trigger in and acknowledge pair and a trigger out and acknowledge pair that I then went and connected to the Xilinx processing system to the FTM signals or fabric trace module. So now this ILA core is ready to capture data in the hardware side of the design on the board, and it's linked directly to the ARM CPUs, the first side of my hardware-software cross-trigger. Once we've run all the way through synthesis and implementation, the very last steps are to generate a bit stream and to then go export this hardware design to SDK. And flipping ahead, that will open up my software design kit and write all the necessary hardware information into that tool. So what you're looking at is the software development kit. This is our Eclipse-based IDE for application development and debug. Your application coders will be very familiar with this environment, again, based on Eclipse. Note, all of my system information, hardware information, has already been written out for me. So these two tools, Vivado and SDK, can be run in parallel. In fact, you can download free versions of standalone SDK for your application coders that will never get near a hardware design. So notice I'm looking at my system XML file. This is all my hardware description, everything I need to initialize the Xilinx processing system. All those files have been written out, they're correct by design and ready for me to start. Now I'll go start a debug session, and one very important option to note is this enable cross trigger switch that I will turn on. And what that does is it hooks up the software side to the hardware side, and I'm ready to start capturing system data. Alright, to initiate the software side of cross trigger, I'm going to go into this test peripheral C program, turn on line numbers, and this print statement is good. I'm going to insert a breakpoint right here. The breakpoint will generate the trigger in signal that will come out of the fabric trace module and trigger the hardware data capture. So last thing we need to do is program the FPGA, and that loads all of the logic information, including the ILA core. I've opened up Vivado in a hardware session that connected to the ILA core that's now downloaded through our system.bit file. I am going to wait for the trigger in signal to go to 1, basically go to high, and I want that trigger to land right in the middle of the data stream so I can see signals before and after. And remember, that trigger in signal is going to be coming from the fabric trace module inside the Xilinx PS. So let's arm the trigger. Notice it's the ILA core is now ready. It's trying to capture data, but no signals yet. And let's go back to SDK and hit resume. My breakpoint is hit, and that generated my trigger. So again, a software breakpoint was used to trigger capturing hardware data. And you can capture exactly the vice versa. You can have hardware breakpoints, stop and halt a program, and initiate debug trace. That was a very quick look at hardware-software cross-trigger in an embedded system. If you want more information, please go to Xilinx.com and look at our Vivado Design Suite webpage or our Software Development Kit webpage. You can also go to Xilinx.com/support and search for UG940, and that is the user guide for the complete embedded design tutorial that I showed you a quick version of today, and you can walk through the whole thing step by step and recreate what we did today. There are a number of other embedded code debug capabilities that our design suite offers. We weren't able to cover those today. If you'd like more information, please look at the rest of the quick videos for Xilinx or for Vivado or for the software development kit. Thank you very much.